Hi, I'm Amani and I'll explain how to solve the first question. So based on question 1 here, we've learned this on chapter 2, the topic of differentiation. So first I'll rewrite the expression by moving the power of 2 into the pad, like this. And then here I'll apply the chain rule to solve this into 3 steps. First, second, and the third. So step 1, we are using the let m equal to and now we are going to use the technique of differentiate of power function, so it will become like this. Second step is we are going to use the let m equal to x plus e to the power of 3x. So it will become like this. And then we are using the technique of differentiate the logarithmic function. So it will become 1 per m. The third step is x plus e to the power of 3x. It will become 1 plus 3e to the power of 3x. Now we are going to combine all the 3 steps to find the dy per dx. So y equal to 2 like this. And we could rewrite it dy per dx equal to to have the final answer here. That's it.
To solve this question, I use the method of implication differentiation. I differentiate both sides of the question with respect to x. For the first term, I apply the chain rule and obtain for the term xy to power of 2. I use the product rule because both x and y are variable. The result is the derivative of the constant 1 is 0. On the right hand side, I use the quotient rule for 2x divide x plus 1 and obtain. Meanwhile, the derivative of dy is, and I combine the all answer is to this. Next, I collect all terms containing dy dx on one side and move the remaining terms to the other side. Therefore, the final answer for dy dx is this.
Hi everyone, today I want to solve this question 3. The question is use the differential to estimate the value of this equation correct to 4 decimal places. So to estimate the value of this equation, I use the differential approximation method. First, I chose the chosen value is 16 because it is very close to 15.8 and is easier to work with. The change in this chosen value and given value is negative 0.20. I define the function as this equation and found its derivative. Then I apply the linear approximation formula. This one, this, and this. Then I apply the linear approximation formula, which is this one. This is the formula. So I just substituting the chosen value is 16 and the total change x is negative 0.20. After I substitute the chosen value, I get this one, and then I try to solve it. I get this, and then I get this, and 4 minus 1 is 3, plus this we need to, and after that I obtain the estimate of value is this one. Therefore, using differential, the estimate value of this equation is 2.9719, correct to 4 decimal places. Thank you.
You might have heard the word calculus from physics or mathematics. Well, might even be in chemistry. Now that my friend had shown you and explained the way to solve the question given, I am going to move on to question 4. You might have wondered, what is calculus actually? Well, I'm here to explain. Calculus is a branch of mathematics concerned with the calculation of instantaneous rate of change, where you can also find this as differential calculus and summation of infinitely many small factors to determine some whole, also known as integral calculus. Conceptually, physics helps with two big ideas, which is how fast something is moving, also known as derivatives, and how much something has built up over time, which is also known as integrals. Calculus is also applied in physics, engineering, and, well, medicine. Well, as explained earlier, medicine also applies calculus in its career, which calculus is used to evaluate the effectiveness of medications and dosage level, which have to be exact, or else the effect will continue to build up over time and become lethal, which show how important calculus is in our everyday life. Well, you might have wondered by now, if calculus is actually so important that it almost applied to everything in life, then why am I not giving an example just yet? Am I just over-exaggerating? Well, not really. Let me give you a common real-life application of differentiation. Well, one of the common real-life applications of differentiation is the use of differentiation in physics and engineering. Differentiation is used to describe motion. For example, the velocity of an object is the derivative of its position with respect to time. The acceleration is the derivative of its velocity. An example we can use is a car is moving along a straight road. The position of a car at any time t is given by s t equals to 5t meters. To find the car's velocity, rate of change of position, we differentiate the position. We differentiate the position function with respect to time, which is vt equals to ds t square over dt equals to 10t m over s. Hence, the car's velocity increases with time itself. Well, you might have wondered, what is the point of learning differentiation? Well, differentiation is learned because it is a fundamental tool for understanding and modeling the dynamic system. Calculus is applied in any career that you might find, or there might even be an instance where you are in a situation where understanding the rates of change, optimization, or the behavior of complex system is essential for making informed decisions. Now, moving on to analysis. Differentiation allows you to break down complex behavior. Differentiation allows you to analyze how a system responds to small changes, predict future states, and even understand its mechanism. Now, we move on to optimization. Many professional challenge involves a heavy critical thinking. In calculus, optimization finds the maximum profit or a minimum waste, which is also the exact same critical thinking which can be used